We did some questions where a car or a kid on a bike skidded to a stop when we learned about forces. There is a way to do this question using F net equals ma. We assume the only force is a force of friction. That force of friction becomes F net is ma. We can solve for the a. Once we get the a, we can do kinematics to find the d. I kind of like this way a little bit better. It's kind of cooler, one-step kind of thing. If we think about it from a conservation of energy perspective, when the kid's riding their bike, they have a lot of kinetic energy. As they skid to a stop, they lose the kinetic energy. All those joules kind of disappear. I'm going to put lost in quotation marks because they're not gone forever. They just are difficult to take advantage of. They've basically heated up the ground a little bit, heated up the bike tire a little bit, but really they're lost because of friction. Kinetic energy is always 1/2 mv squared. If we're talking about the energy due to a particular force, we can say that energy, which is the same as work, is force times displacement. Since we're talking about the energy due to friction in this case, we can say that it's the force of friction multiplied by displacement. Now it kind of falls apart. The 1/2 mv squared, friction from what we talked about last unit, is always mu times Fn. It doesn't say anything about this bike being on an elevator or trampolining into the air. So the normal force is a boring case situation. The normal force is mg, and then we're multiplying that by displacement. The m's end up canceling out. Doesn't matter how heavy our bike is. We get 1/2 v squared equals mu g d. From energy, that connects the initial speed of the biker before they started the skid to how far the kid's going to skid, connected to the coefficient of friction. For the way I've worded this example, the biker, we know the speed. I made up a number of 8. We know the mu. I made up a number of 0.6. G is always 9.8. We can solve for that. We can solve that for the d. You can verify on your calculators, but I get 5.4. It would have taken a couple more steps to do this with forces. We've done F net equals ma to get the a, and kinematics to get the d. But in energy, we can do it basically in one step.